In the breadth of the night sky, a huge dark red star, quite possibly one of the most splendid and easily recognizable heavenly objects, overwhelms the horizon. Situated in an area far beyond our understanding, it has the potential to radiate a measure of energy that could rival the combined output of countless stars. This tremendous astronomical entity is possibly nearing the precarious edge of a disastrous event that could soon release one of the most powerful eruptions of energy ever seen, an emission that may eclipse a billion suns. Are we prepared for the aftermath that such an event could cause? This gigantic red star, frequently called Goliath, lies at the forefront of Earth's view and has become a subject of intense interest and discussion among both researchers and the general public. Recently, it has undergone a significant transformation, which has sparked considerable concern within the scientific community and fueled debates about its potential future. The most concerning scenario is that this change might be the early sign of a supernova, a catastrophic celestial explosion signaling the end of the star's life cycle. After exhausting its nuclear fuel, the star could collapse under the weight of its own gravity, resulting in a horrendous blast. The mere thought of such an event raises alarms not only among scientists but also among those of us living on Earth, as the possible threats to our planet could be immense. This particular star, easily identified overhead by its intense red hue, is known as Alpha Orionis. It holds the title of the largest and most brilliant star within the Orion constellation. Through instruments like NASA's Hubble Space Telescope and other observatories, astronomers have been monitoring the star's behavior, and in 2019, it experienced a significant loss of mass. This type of event is intriguing for stars of this nature and has captured the attention of astronomers worldwide. While the Sun regularly undergoes coronal mass ejections, the specific event observed in Alpha Orionis has raised new questions about the final stages of massive stars and how they behave just before they meet their explosive end. As researchers continue to monitor Alpha Orionis, they remain uncertain about its precise distance from Earth. Some estimates place it as far as 1,200 light-years away, while others suggest it could be about 724 light-years distant. Determining the exact location of stars like Alpha Orionis proves challenging due to the immense distances involved and the peculiar properties of red giants. Regardless of its exact position, this star remains one of the most striking objects in the night sky, emitting several times more light than our Sun. However, with this brilliance comes a significant downside: its rapid consumption of nuclear fuel. The star is burning through its reserves at an accelerated rate, speeding toward the end of its life cycle. Eventually, it will run out of fuel, causing it to collapse and possibly form a neutron star or even a black hole, depending on how the explosion unfolds. A major question arises: could Alpha Orionis pose a threat to Earth? If a supernova were to occur within a few light-years of our planet, the consequences would be catastrophic. A supernova can release an overwhelming amount of light, potentially outshining entire galaxies. This brings up an important consideration. Regardless of whether Alpha Orionis is located at an immense distance, the repercussions of its explosion may still have sweeping effects. Interestingly, the most recent supernova observed in our galaxy occurred in 1604, and humanity has yet to witness another such event locally. However, in 1987, a significant supernova erupted in the Large Magellanic Cloud, located 169,000 light-years away. While this explosion affected its surrounding environment, it posed no immediate threat to Earth. Nevertheless, these events serve as a reminder of the vast scale and potential dangers associated with such cosmic explosions. The possibility of a danger zone around a supernova, particularly one that could occur relatively nearby, has raised concerns about the potential risks to life on Earth. However, when viewed in the broader context of the universe, supernovae are relatively rare and much smaller in comparison to the far more powerful gamma-ray bursts, GRBs. GRBs are far more destructive, capable of obliterating entire biospheres and inundating planets with lethal radiation. For example, GRBs can destroy a planet's ozone layer, leaving it vulnerable to harmful radiation from its sun, which could have long-term consequences even after the burst itself has passed. This looming threat has been the subject of ongoing research, which has provided new insights into the potential risks posed by stars that end their lives in such spectacular fashion. When massive stars detonate in supernovae, they can release brightness far beyond that of an entire galaxy. The sheer brilliance of these explosions raises the question: what would happen if Alpha Orionis were to undergo such a transformation? If a supernova were to occur, it could become the second brightest object in the sky, just behind the Sun in terms of visibility. Even though Alpha Orionis might be far from Earth, the energy of the explosion could be so intense that it could potentially be visible during the day. Such a glaring display would cast shadows without any attempt at subtlety, offering a striking yet terrifying spectacle for anyone observing it. While the visible light from a supernova is undoubtedly awe-inspiring, the real danger lies in the high-energy radiation that accompanies it. This radiation, typically in the form of X-rays and gamma rays, can have far-reaching consequences. One of the greatest concerns is its ability to deplete Earth's ozone layer. Without this protective layer, life on Earth would be exposed to dangerous levels of ultraviolet radiation, potentially leading to catastrophic events. And the risks don't end following the explosion. Over time, the remnants of the supernova, including high-energy radiation and shock waves traveling at nearly the speed of light, would continue to pose threats. Such debris could travel through the solar system, further damaging the ozone layer and exposing Earth to even more destructive radiation, increasing the risks. Moreover, the long-term effects of a supernova's energy release could persist for millennia, potentially causing lasting damage to the planet. Interestingly, some studies have suggested that may have as of now been impacted by cosmic explosions. Previously raised degrees of iron-60, a radioactive isotope formed in cosmic explosion blasts, have been tracked down in remote ocean residue and lunar soil, suggesting that Earth has experienced the aftermath from a cosmic explosion event at some point in its land history, potentially within the last few million years. At present, no cosmic explosion competitors near Earth are believed to represent an immediate danger based on our current understanding of gamma-ray risks. However, continuous examination continues to reveal new dangers, especially from supernovae that emit long-range deadly radiation. These supernovae occur when a star, approaching the end of its life, is surrounded by a huge plate of material. The shock wave from the blast interacts with this plate, creating extraordinary X-ray radiation that can travel huge distances through space, potentially affecting planets within a 150 light-year radius. Luckily, no such candidates have been identified near Earth yet. This research has provided new perspectives on the concept of the habitable zone, the region of space where conditions are ideal for life. Apparently, this habitable zone might be more confined than previously suspected, with the outer regions of galaxies lacking adequate star formation activity to support the development of rocky planets. In the meantime, the inner regions, where stars form and die more quickly, may pose their own dangers due to the continuous occurrence of cosmic explosions. As scientists continue to investigate cosmic explosion remnants, they are finding that the debris left by these enormous events can lead to new stars forming from the ejected material. This recurrent process highlights the interconnected nature of the universe, where the death of one star frequently prompts the birth of others. Furthermore, supernovae have proven to be invaluable for measuring astronomical distances. Astronomers use type Ia supernovae as standard candles to determine the distances between galaxies, refining our understanding of the universe's vastness. The remnants of supernovae, made of the material ejected during the blast, play a critical role in the development of new stars. These remnants act as stellar nurseries, where new stars are born from the gas and dust left behind. This process demonstrates the recurring nature of stellar life cycles, where the death of massive stars provides the building blocks for future generations of stars. This ongoing cycle of creation and destruction drives the evolution of galaxies and contributes to the ever-changing structure of the universe. As astronomers continue to study these remnants, they are discovering that new stars can form from the gas and dust in these regions, even thousands of years after the initial blast. Cosmic explosion remnants, with their diverse and complex compositions, are some of the universe's most significant sources of heavy elements like iron, gold, silver, and uranium. These elements are created in the extreme conditions of a cosmic explosion blast. These elements are then dispersed into the interstellar medium, enriching the matter that will eventually form new stars, planets, and even life itself. Without these heavy elements, the solar system and our very existence wouldn't be possible. Supernovae are therefore not just catastrophic events. They also play an essential role in the creation of the very elements that make up the stars and planets we observe today. In addition, the study of supernovae has expanded our understanding of the universe's development. By observing the brightness of type Ia supernovae, which occur when a white dwarf in a binary system reaches a critical mass and explodes, astronomers can measure astronomical distances with remarkable precision. These standard candles allow scientists to gauge the size of the universe, providing fundamental information about dark energy and the accelerating expansion of the universe. The ability to accurately measure astronomical distances has revolutionized astronomy, enabling scientists to map out the structure of the universe on a grand scale. However, the potential risks of these massive events cannot be ignored. Although the likelihood of a nearby cosmic explosion affecting Earth is relatively low, the long-term consequences of such an explosion could be far-reaching. As previously mentioned, supernovae release intense radiation, which could disrupt the local solar system's environment. This radiation could interact with Earth's atmosphere, depleting the ozone layer and exposing life on Earth to harmful ultraviolet radiation from the sun. Without the ozone layer, survival on Earth could become extremely difficult, if not impossible. Moreover, the shock waves from a nearby cosmic explosion could affect the structure of the solar system. These shock waves would compress the interstellar medium, potentially triggering the formation of new stars or altering the orbits of objects within the solar system. In the worst-case scenario, a nearby cosmic explosion could disturb the delicate balance of the solar system, leading to catastrophic changes in planetary orbits and possibly even the destruction of Earth. The study of supernovae and their remnants also raises intriguing questions about the future of the universe. As stars die and cosmic explosions occur, the remnants they leave behind can eventually form black holes or neutron stars, some of the most mysterious and extreme objects in the universe. Black holes, in particular, are regions of space where gravity is so intense that not even light can escape. They are believed to be the final state for the most massive stars, and their formation remains one of the most fascinating phenomena in modern astronomy. Despite their destructive nature, supernovae are essential to the ongoing evolution of the universe. The materials they release into space serve as the foundation for future star formation and the creation of new planetary systems. As new generations of stars are born, the cycle of stellar life and death continues to drive the evolution of galaxies and contributes to the ongoing expansion of the universe. In conclusion, while the potential threat of a cosmic explosion remains a distant concern for Earth, the study of these events is crucial for advancing our understanding of the universe. Supernovae not only provide insight into the cycles that govern the lifespans of stars, but also offer vital clues about the chemical composition of the universe and how galaxies evolve over time. As we continue to explore the vast reaches of space, our understanding of these dramatic cosmic events will grow, offering us a clearer picture of the universe's past, present, and future.